going on, guys? Welcome back again. Today we're gonna carry over with Windows Forensic, and it's gonna be the part 2. So in part 1 we talked about Windows Forensics. Specifically, we mentioned or we discussed registry forensics. Now in today's video we're going to target the file system as a place to gather artifacts. So remember, guys, in forensic or in computer forensic, our aim is to gather artifacts. So these artifacts are indications of activity. So mainly we can use the registry, which what we did in the last video. We can again use the file system. So in the registry, in the previous video, we discussed how to perform registry acquisition and analysis. Now, if you want to use the file system as a place to gather the artifacts, we will want to do what is called, again, the data acquisition. So when it comes to file system, we want to perform what is called disk cloning, or we will want to take a disk image. Okay, so say you have a computer system or an OS where you want to conduct your investigation. So what you have to do, you have first to perform data acquisition, which can be done using disk image. So taking a disk image of the entire OS. Now this can be done through several tools. In Windows, you can use FTK Imager. That's one example. In Linux, you can use DD. Okay, so after we gather the evidence, we want now to start the process of data analysis. We want to see where we can go to gather the artifacts. So first, before we talk about this, let's first explain the substantial differences between the FAT32 and the NTFS. So file allocation table file system is an older file system than NTFS, and they are both for Windows operating system. Now these days all operating systems are using NTFS. So what is the huge what's the limitations that pushed Microsoft people on Microsoft to create a new file system? So basically, in the file allocation table, we had limited file size. And I remember that it was 32 gigabyte. So they created NTFS, okay, to overcome this limitation. So basically in NTFS, you overcome the file limitation, and you have security features. You have what is called the journaling. Journaling is keeping track of the changes performed on the disk, so that when a crash happens, you will be able to recover the disk easily. And we have again compression to save disk space. All these features came with NTFS. Now that's why we will need to understand more about the NTFS file system before we go any further with disk imaging. So NTFS file system, we have the security through encryption, we have the journaling, keeping track of changes, and we have the compression to save disk space. Now moreover, we have what is called the MFT. So MFT stands for the master file table. So the master file table holds information about all the files and directories. The first thing that the master file table contains in NTFS file system is the MFT. So MFT is the first record in the volume. And again, MFT contains information about the files and directories. Inside the master file table, we have the log file. So the log file here stores the transactional logging of the system. So log file is created because by virtue of the journaling feature to keep track of the changes. So now that we understand the basic difference between NTFS and file location table, we want now to understand the methodology of gathering evidence from NTFS powered disks. So basically, the first target or the first place where we want to dig for artifacts is the MFT, because the MFT holds all the information about the files and directories. Usually we use a tool, a specific tool, a dedicated tool for exploring the MFT. It is from Eric Zimmerman tools, MFTE CMD. We're going to use this tool in the practical scenario. Now let's talk about other places where we can gather evidence. Okay, we can recover deleted files. Now here's the thing. Recovering deleted files by its own, it's not a forensic procedure, but it is part of the forensic procedure. So basically, let's say we acquired a disk image, okay, and we will want to recover the deleted files. Before we know how to recover deleted files, we want to understand what happens when you delete a file. So basically, we knew from the previous board that all the files and directories, the details, the location are stored in the MFT. So basically, the MFT is a table here. Okay, the table contains, in every single entry you have details about a single file. For example, you have the location of the file, you have the size of the file, and maybe you have the changes done on the file. All of this for one file. Now say a user deletes this file. Now what happens when a user deletes this file? The location, okay, or the entry in the table is deleted. So there will be the spot here will be emptied and will be available for another file, but the actual content is still on the disk. You see what happens? So we only delete the reference to the file. The reference to the file is the entry in the MFT. That's MFT, and here we have reference 1, 2, 3, 4, 5, 6 for all files. So when we delete a file, we only delete the reference or the entry that contains information about the location, the size, and the changes done. So they say that we deleted the reference here. What's gonna happen? It's gonna become available for another file, but the actual content is still stored on the disk. You can take it as when you delete a partition. So say you have a disk. Under the disk you have partition 1, you have partition 2, and you have partition 3. So, and let's say you have formatted partition 1 and you deleted the entire partition. What's gonna happen? Let's say partition 1 is 50 gigabytes. So when you format this partition and delete it altogether, it's gonna appear as unallocated space. So the space is still there, you can use it, but the actual partition is deleted. The same can be applied to deleting files. So when you delete a file, again, we delete the reference that includes the location, the size, and the changes, but the actual content will appear as something similar to unallocated. It is still on the disk, okay? It is not deleted. Now the only way to completely delete the file is to overwrite its contents. So unless we really control the MFT, we will not know for sure if we store another file in the same location will overwrite the content of the file. So the content is here. Unless I store another content over this content, the actual content of the deleted file will stay in the disk. So I will need to use specialized tools called wiping tools. The wiping tools will make sure that all these references, okay, will be overwritten, and the actual content in the disk will be located and overwritten with maybe randomly generated content, bits and bytes, you know. So that's the process of that's how it works. Now, in forensics, we want to recover deleted files. Okay, now it can be easily recovered as long as it wasn't wiped. So recovering deleted files can be performed using several tools. We can use Autopsy. Autopsy has a module to recover deleted files. Okay, now what is another place to gather forensic evidence in the file system or in the disk image? We have what's called the prefetch files. So in prefetch files, it's located under C, Windows, prefetch. Now prefetch files stores what is called the executed programs. It keeps tracks of the programs that you execute, or mainly we can say evidence of executions. It contains the last run times of the application, the number of times that the application was run, and any files and device handles used by the file. And again, we can use a specialized tool to explore the prefetch files. We will use that in the practical scenario. 4, we have the it's not writing. We have what is called the Windows 10 timeline. Now Windows 10 timeline, if the target OS was Windows 10, it again stores the recently used applications in a SQL DB. We can also explore Windows 10 timeline using Eric Zimmerman's suite of tools. Okay, now I want to jump to 5 on the list. We have what's called Windows jump lists. So the Windows jump list, if you remember, they are the places that show on Windows operating system on the left. They are kind of shortcuts where you can access your recent files quickly. So Windows jump lists is another place where we can look for recently open files and programs. We can also explore them using specialized tools from Eric Zimmerman's suite of tools. Another place to gather recently opened programs and files is the shortcut files. The shortcut files can be found in C, users, here put a username, app data, and then you got roaming, Microsoft. It's really a hell of a path. Windows, and then recent. It suffice to say that shortcut files can be explored to find out about recently opened files and documents. Now, and the last on the list in this video is going to be exploring USB devices. Now, we know from previous video that the USB devices plugged into the PC can be unveiled and uncovered using the registry, right? But again, we can still use other places in the file system to uncover the USB devices connected or previously connected to the system. It is in the setup API dev log. This file can be found under C, Windows, I and F. Look for this directory in your file system and we'll find this file. Exploring this file will enable you to find out the connected devices. Now let's jump to a practical scenario. Alright, so to demonstrate the practical scenario of the theory we discussed, we're going to use the Windows Forensics 2 room from TryHackMe. All the lab material is credited to this room. So we're going to start first with exploring the MFT or the master file table. So as you can see guys, if we open the machine, we have the triage directory which contains all the information we need to investigate. And under Easy Tools, we have the Eric Zimmerman's tools or Eric Zimmerman's suite of tools that we can use to perform the investigation. Okay, so let's go to task 3, and we have here these two questions that we will need to answer. Okay, so C users, THM, this will C, the attached VM answer the questions correctly. Okay, so under C here, as you can see guys, we have these files. We talked about these files at the very first of the video. So we have to analyze now the MFT. To do that, let's now open an elevated command prompt, run as administrator, and start the analysis. Alright, so let's see what we have. Now we want to use MFT Explorer, MFT CMD. This is the tool you want to use. Now this tool has a syntax. Let's explore the syntax here. MFT, okay, dash F, the path to the file we want to analyze, and that will be in CSV. So MFTE, okay, dash F, and the path is already given in the task. We just have to supply the file name dash CSV, and let's now choose the output to be in the desktop. So I'm gonna take the path here again and put desktop. Now the tool will extract all the relevant information in a CSV output. Now we can explore the output file using Microsoft Excel, but unfortunately the machine doesn't have Microsoft tools, so we're gonna have to resort to again Eric Zimmerman's suite of tools and use Easy Explorer. Let's see here. So take a look at this. This is the path we want, and this is the file. And as you can see guys, we got the size information along with many other information we can see here. References, whether it is a directory or not, and the last modified time. That's the wealth of information the MFT table contains. So we answer with this one. What is the size of the cluster for the volume? What is the size of the cluster for the volume from which this triage was taken? The machine is slow. So again, triage. We open this, we go to disk, and we have again the boot file. So we want to analyze this file instead. So back here, we replace MFT with boot. Okay, in the output we can check out this cluster size equal to 4096. That would answer the question here. Okay, so now let's move on to the next task where we explore how to recover deleted files. Before we do that, let's close this one and open the popular tool Autopsy. So in the recovered deleted files, we have a couple tasks to answer. Okay, so you're asked to recover some deleted files and to extract the node found in the text file. So we have to use Autopsy to perform this. Let me check out the nodes here, scrolling back, remember how this works. So in Autopsy we can recover deleted files. Okay, So first, let's create a new case, and we name it THM. Clicking on next. Case number 1, and just basic information to get started. So generate a new host based on data source name. I'm gonna say next, and we're gonna specify the option disk image or VM file. And now we will want to browse to the path. Now the path can be found under desktop, and here we want to specify the disk image of the USB device. So it's a disk image taken from a USB device. We're going to click next, and we're going to uncheck everything from here. We only need a couple modules. So to recover deleted data, the extra modules are not needed to perform the analysis. So this is also stressed out here in the task if you want to follow the instructions correctly. So we're going to deselect everything and click on next. And then we click on finish. So under data sources, as you can see, we have the USB we just added. So we click on USB, the device itself, and we can see the file system. And if we scroll down here, we can see 3 files with the red X check mark here, which indicates that the file is or was deleted. So we have one Excel file named TryHackMe and another text file named TryHackMe2. This will give you the answer for this question and the other one. Now back to this question, recover the text file from question 2. Let's say we want to recover one file. We're going to right click on the file and select extract files. We select the destination for the file and we click on save. Then we're going to go ahead and open the file. Let's see, and it is correct answer. Okay, now let's move on to the next task. Next task is evidence of execution. Evidence of execution, again guys, we mentioned this in the room where we will need to tackle a couple locations such as a jump list and the prefetch files. So let's collapse this file, open this task and scroll down. Okay. How many times was GK or GCape? It's a forensic tool, by the way, Cape Forensic. How many times this program was executed? The tool name is PECMD, and the same logic here. We have to give it the path of the file we want to analyze and the output in CSV. So PECMD. Okay, -F. Now the path is in the triage C, and I guess it is Windows, and we have the prefetch. Okay, so C, or that the path is already given here. Prefetch. Oh wait, we forgot to provide the CSV output, CSV, and we're going to select desktop as destination. Okay, so thing is here, -F should be -D. So now that we have the CSV file, we're going to go to The tool, EZ tools, we're going to select EZ viewer, and we're going to view the output with the EZ viewer. So after opening the file, as you can see, we see the column executable name, and it contains the executables that will run. Among them, if we do a quick eye search, we can highlight gcape, and we can highlight as well how many times it was run. As you can see, we have the column run count. It indicates that this gcape was run 2 times. So thus the answer is 2. What is the last execution time of gcape? So we're going to look for the appropriate column, the last run of gcape, and we can see it was last run on 12/1/2021. That's the answer for this question. Okay, so the next question, when Notepad was opened, how long did it remain in focus? So here again, we are looking to extract information or details about the open files and executables, but this time we want to find out about an application. How long did it remain in focus? So we will want to use the Windows timeline. So we're going to go back to the suite of tools. I'm going to keep this open because it takes time to reopen it again in case we need it one more time. Okay, so Eric Zimmerman's tools, DIR. We're going to use a tool called WXTCMD to analyze the Windows timeline. And we're going to provide the path. So the path we want to provide as an input for this tool is the path of the Windows 10 timeline, the exact file, which is a SQL database. It can be found in C, and we're going to need to highlight the user profile. So we go to users, and the user is DHM4N6, and then we have up data, local. Under local we have connected devices platform, and as you can see we have the activities cache. That's the database we want. Okay, so what we're gonna do, we're gonna copy the exact path and provide it as an input to the tool. Okay, so we give the input here, and then one more time we want to specify the path, so the output path. So let's see here, wx dash dash, again it's going to be in CSV. Okay, dash dash CSV, and we're going to specify the desktop as the output path. Okay, let's see here. So we have 2 output files. Let's go ahead and open them. Now these are output files for the previous tools we used for the MFT and the prefetch files. We're going to need to use this one. Alright, so assuming now we have the file, let's search for Notepad. And we have 2 results: display text and executable. Under the executable column we have many entries highlighting the Notepad, but which one is the correct one? We're gonna have to go back to the question, when Notepad was opened, 11/30/2021. So last open time, let's see here, this is the last modified time, this is the last modified on client. Start time, the start time here is 30/11. So this one open on 30/11, the timing was 10:56. So that's the correct one we want according to the time mentioned in the question. How long did it remain in focus? This also can be found here. So the duration is 41 seconds. What program was used to open C users THM desktop cape the changelog? So here we're looking to find out the handles or the files opened by the recently used programs. Okay, so up until now we used the prefetch and we used the Windows 10 timeline to find the recently opened programs and the associated details. Now we want to find the handles, okay, meaning the files and the processes used by these programs. So here we want to find out what program was used to open the change log. So this is the file used by some program. It's not bad, but we want to find out this. How are we going to do this? So we're going to use the jump lists. So back to the command line, and here I'm going to search for jump list. So this is the tool, GLECMD, and we provide the directory. So we will want now to supply a directory, not file, to search within. The directory we want to search for, or the jump lists, can be found. Let's go to the disk image and we go back to the local up data and we highlight roaming, click on roaming, Microsoft, and then Windows, recent, and let's see here, automatic destinations. So all of these files contain information about the recently opened programs, files, and their handles from the jump list. So we're going to provide this path as an input. So here -D for directory. If it is a file, a single file, we're going to use -F, -CSV, and the output will be under desktop. Back to ESET tools. So we highlight automatic destinations. Okay, great. Windows Explorer, and we have Windows Explorer, but there is one entry here, changelog. Look at this. The changelog as a path was used by an application, okay, whose description matches Notepad. So that would answer this question. Okay, now to next task, file folder knowledge. Okay. So we have two questions. When was the folder C users THM desktop reg gripper last opened? And when was the above mentioned folder first opened? Again, details about the opened files and directories. But for this task, we're going to use something different than prefetch, jump lists, and Windows 10 timeline. We're going to look into shortcuts. The shortcuts. So we have to use another tool from Eric Zimmerman. So we go back here and we use what is called LE. Okay, so in LE here we provide the path to the shortcuts. So we go back to the disk image and we want to go back to up data, roaming, Microsoft, Windows, recent. That's the directory we want to supply as an input. The recently opened files and directories. So here -D before directory, and then -CSV. It's going to be in CSV format. Now thing is, this time I cannot find the program I'm looking for. So basically I don't know what happened to the machine, but thing is, if you search with the rig gripper, you will be able, guys, to find the last opened and the first opened from here. But this, upon this attempt, it didn't work. I don't know why. At the first attempt, the data was here. Anyway, guys, you get the idea. Now for the last task, it's about external devices. So here there is one question, which is where you will look to find out the last and the first connection times of a removable drive, which is this file that we talked about earlier. It contains a log of all the USB devices connected to the device. So that was it, guys, for today's video. I hope you enjoyed it, and I'm gonna see you later.